Okay, here's some slides or a short video on TST switches. And a TST switch is a time-space-time switch, and it is a three-stage switch where the first and the third stages act in the time domain, and the middle stage, central stage, acts in the space domain. So the first thing we have to do is look at time division multiplexed signals. And the idea here is that on the input we have three different signals, and then we put them through a multiplexer, a TDM multiplexer, time division multiplexer, and we can create a single signal whose bit rate is the sum of the bit rates of the inputs. Okay, and so here we have signals A, B, and C, and these are output onto a single line with three different time slots, one labeled A, one labeled B, one labeled C. And the signal from input A occupies the time slots labeled A, and so on with B and C. And so in this way, for example, if A, B, and C were all 1 megabit per second signals, then the multiplexed signal would be 3 megabits per second in this simple picture. Okay, and the interleaving could be either bitwise or bytewise. So for example, an A here could represent either a bit from stream A or a byte from stream A, or some other larger chunk. And what we'll do is we'll draw this as a single line, and I'll put three time slots A, B, and C here to mean that this is a line with three time slots. And now I want to show you the picture of the switch, which is a TST fabric. So this has three stages to it. And in this example, what we're doing is we're taking three different lines, each with just two time slots for simplicity. And we would like to switch these 6 possible inputs to the 6 possible outputs on the output side, which also consists of 3 lines, each line with 2 different time slots. And so the question is, how do we make this 6 by 6 switch? Okay, and what we're going to do is we're going to make a 3-stage switch, very much like our Clos network that we've looked at when we did space switches. And I'll draw it like this. I'll draw the first stage is labeled a T stage. So this first stage is doing time slot interchange. And when you have only 2 time slots, either you're keeping them as they were, or you're switching the two, meaning that time slot number 1 on the input could be mapped to either time slot number 1 or time slot number 2 on the output. And so we have 3 different time switches, time slot interchange switches at the input, 1 for each of our inputs, and then we run those 3 signals into a space switch. And because we have 3 incoming signals, we need a 3 by 3 space switch. Symmetrically on the way out, we have another time slot interchange stage here. And the thing to realize about this is, due to the timing, this 3 by 3 switch, in order to make this configuration as flexible as possible, this 3 by 3 switch can change its spatial mapping of inputs to outputs once for every time slot. So in other words, for time slot number 1, the 3 by 3 switch may have one configuration, whereas for time slot 2, it has a different configuration. Okay, and so this central switch changes configurations at each time slot. Okay, well, instead of drawing it like this, and instead of drawing our 3 by 3 switch and saying it has to change its configuration at each time slot, first of all, I'm going to draw these time slot interchanges as 2 by 2 switches, and then I'm going to draw 2 copies of the 3 by 3 switch, 1 for each time slot. And this is what it looks like when I do that. So now I've got the same 3 input lines, and I'm saying that each time slot looks like a separate input to a 2 by 2, and similarly the same number of time slots on the output of a 2 by 2. And so these time slot interchange, TSI switches, look like 2x2s here. And then for the 3x3 space switch, I draw 2 copies of it, one for each time slot 1, time slot 2, and symmetrically on the way out with another set of 2x2 time slot interchange switches. Due to the timing constraint here, what we're going to do is we're going to keep K equal to N. Well, first of all, notice that this now reproduces the Clos network configuration. This is just like it, where on the input side, on the Clos network, we divided our big N number of inputs into some number of groups, where big N was divisible by little n, where each of the groups had little n number of inputs, so that little n had to divide big N. Well, in this case, little n, the number of time slots, little n is equal to the number of time slots in each incoming line. So you don't really choose n here. The other thing that we're going to do is we're going to choose k equal to n, and that means that the time slots on the output of the time slot interchange switches are in sync with the time slots at the input. Okay? Having more time slots on the interior of the fabric should be possible, but we won't deal with that. And so k is equal to n here. So this looks like a Clos 3-stage switch with k equal to n. And so this is essentially a special case of that Clos 3-stage network. Okay, and so this is the type of thing we're going to be analyzing in these problems. And you can now take this switch and, for example, ask that the input on input 2, time slot 1 on input 2 be mapped to time slot 2 on input 1 at the output. And we can figure out a way of setting up these switches to perform that mapping. So for example, if time slot 1 is going to be mapped to time slot 1 on input 2 is going to be mapped to time slot 2 on output number 1, we could do something like this. Okay, so there's an example of that mapping, and there are many ways of doing it. So that's a quick review of the TST switch configurations.